The Saab Gripen JAS-39 is considered to be one of the world's best lightweight multi-role combat aircraft. It's also one of the most unique, not because of its state-of-the-art design, but because it's a warplane built in the relatively small and neutral nation of Sweden. Sweden is a proud country that has historically maintained its neutrality as nations around it engaged in all-out warfare. But the Swedes have learned that a policy of neutrality must be maintained through strength. In times of war, the slightest sign of weakness or lack of resolve could result in the loss of cherished freedoms. Despite many challenges, the Swedes have worked hard to establish an aircraft industry that is second to none. And because of Sweden's limited resources, Saab has been given a virtual monopoly on the manufacture of aeroplanes. But rather than take their situation for granted, Saab has built aircraft that are highly regarded for their quality and their ability to take on just about any opponent. The unique nature of Swedish industry led to Saab making one of the best automobiles in the world. But where most automobile companies test new technologies through racing, Saab also draws on its long experience with aircraft development. When World War II was coming to an end, Saab managers realized that orders for military aircraft would dwindle. They faced the prospect of laying off a skilled workforce and losing the industrial readiness desired by the Swedish government. Making high-quality automobiles seemed like the logical next step. Saab used the same machine presses for the Type 92 car that they used in making components for aircraft such as the B-17, Saab's original design, which took to the air in 1940. The twin-engine B-18 guarded Sweden's coastlines well into the 1950s. The J-21's unique design led to the world's first ejection seat. The jet-powered J-29, called the Flying Barrel for obvious reasons, evolved into the sleek Draken, the powerful Viggen, and the cutting-edge Gripen. The Gripen is Sweden's first multi-role fighter aircraft, a plane so advanced it could hardly have been imagined by Swedish aircraft pioneers at the turn of the century. Sweden's aircraft industry was founded in 1914. It enjoyed the interest and support of the King. The first aircraft built in Sweden were foreign designs. These included models by Farman and Albatross. Soon, Swedish companies were also making and exporting their own designs. One problem faced by Swedish aircraft manufacturers was the need to import engines. This obstacle to success grew worse with the onset of World War I. Another problem was the Swedish Army, which, like other military establishments around the world, felt that the aircraft was a novelty that should be relegated to reconnaissance missions. But like the others, the Swedes saw the aeroplane's mission evolve during World War I from reconnaissance to dogfighting and bombing. After World War I, the Swedish government short-sightedly cancelled aircraft orders from private industry. But reconnaissance aircraft, trainers and fighters were turned out by the military in numbers sufficient to keep a proud tradition alive. Germany's Ernst Heinkel designed float planes built in Sweden by a company he owned. Germany was circumventing the Versailles Treaty, which prohibited the manufacture of warplanes. Junkers also opened an aircraft plant in Sweden. Many of these aircraft were allegedly sent to Germany, but no records exist to prove it. In 1925, with great public support, the Swedish Parliament voted to establish an air force formed out of the country's Army and Navy aviation units. The year that followed had its share of successes. The first parachute jump in 1926 was taken by a pilot who was bailing out of an aircraft that had gone out of control. Efforts to build efficient Swedish-designed aircraft were hampered by a lack of resources and competent engineers. Over the next few years, even experienced pilots had their hands full flying unreliable designs. The Swedish Air Force did not lack for volunteers, but unfortunately for these would-be pilots, there was a shortage of enthusiasm on the part of the officers who'd been transferred from the Army and Navy to head newly formed Air Force units. With conflict building around the globe, the Air Force continued to gain support. In 1935, the Defense Committee recommended that the Air Force be enlarged. In 1936, the Swedish Parliament voted to create an Air Force Academy. For the first time, pilots were trained based on their desire and fitness to fly, rather than being taken from other services. The private aircraft companies had no experience building all metal aircraft, and they still had to compete with military facilities for construction orders. In 1936, the Swedish Air Board secured a license to build the Focke-Wulf FW Steelitz trainer. It was designated the SK-12 by the Swedish Air Force. In 1937, the arms maker Bofors formed the Saab Aircraft Corporation. This was done at the government's request. It was intended that Saab work cooperatively with another Swedish aircraft company, ASJA. A number of Air Force responsibilities have been taken away from the Navy, such as close air support of the commercial fleet and beating back invasion forces heading towards Sweden across the Baltic Sea. But Sweden's military had concentrated on acquiring bombers. This meant there was a shortage of fighters in the Swedish Air Force as Germany began its conquest of Europe in the late 1930s. Sweden turned to the American aircraft maker Seversky. Its founder, Alexander Seversky, had traveled to Sweden in 1939 and demonstrated his P-35, the forerunner to the legendary P-47. The P-35 was the first single-seat, all-metal pursuit plane to go into service with the American Army Air Corps. It had retractable landing gear and an enclosed cockpit. The Swedish Air Force ordered 120 of them, but only 60 were delivered. An embargo blocked export of the rest. A mostly unsung hero in Sweden's effort to protect itself from the war growing around its borders was the FFVS J-22. The J-22's chief designer, Bo Lundberg, began work on the project in 1940 after returning from America. Lundberg had been overseeing the manufacture of the Vultee P-48 Vanguard for the Swedish Air Force. But because of the wartime embargo, the Vanguards were never delivered. The J-22 was built outside the overburdened Saab organization by a large number of subcontractors. The basic structure of the fuselage was welded stainless steel covered by load-bearing wooden panels. The engine was a Swedish copy of the Pratt & Whitney double Wasp radial engine, generating 1,100 horsepower. It flew for the first time in September 1942. Two fighter versions were produced. The J-22A had two 8mm and two 13mm cannons. The J-22B had four 13mm cannons. Deliveries to fighter wings began in October 1943. An aircraft in Swedish service had to be rugged because the Air Force did not rely on established airfields, which they believed could be too easily bombed and put out of commission. And since the Swedes didn't have many aircraft, it could not afford to leave them to vulnerable attack. The shortage of aircraft also led the Swedes to develop techniques which allowed them to make the most of their limited resources. Crews were trained to repair, refuel and rearm an aircraft in as little time as possible. When one pilot returned, another was ready to fly in his place. His aircraft was made ready while he sat in the cockpit. The J-22's retractable landing gear was unusual. It was placed well forward and equipped with a mechanism that enabled the wheel doors to close when the gear was down. This reduced drag on takeoff and prevented dirt from collecting in the wheel wells during taxiing, takeoff and landing. It was even designed with a retractable ski undercarriage, but this was never produced in quantity because of improved snow removal equipment. The performance of the J-22 compared favorably with fighters of other nations. Despite its limited power, the J-22 could outclimb the North American P-51 at altitudes below 5,000 meters. A total of 198 J-22s were manufactured. All but 18 of these were completed before a metalworkers' strike stopped production in February 1945. The Swedish Air Force completed the rest. A legacy of the Swedish government's bias towards bombers and reconnaissance aircraft is the Junkers Ju-86, which flew in Sweden as the B-3. This twin-engine bomber was built in Sweden through a license agreement reached with Junkers in 1938. But Swedish officials knew that it was slow and would be no match for the modern fighters. It was the last medium bomber in the Swedish inventory. The government stopped production in 1940, but by that time Russia had invaded Finland and Germany had captured Norway. Sweden saw its strategic position as critical. But fortunately in 1937, ASJA and Saab had begun working under government contract to build their first all-Swedish design, the B-17, a single-engined aircraft. The prototype first flew as a reconnaissance aircraft in 1940, but following that, company officials proposed that it be built as a light bomber and dive bomber. As a dive bomber, the B-17s required stronger wings, so the landing gear was not retracted into the wing, but folded back under it. The struts were covered with an aerodynamic fairing, which also acted as an air brake. It was also designed to operate from primitive areas. This continued the long-standing policy of maintaining aircraft away from population centers. Self-sufficient Air Force communities were established in forests and other remote areas. Again, aircraft readiness was only a few minutes away. The B-17 was a multi-role aircraft, but reconnaissance was still one of its most important missions. The reconnaissance version entered service in 1942. A typical mission started with a conference between the pilot and his commander. An objective that included land and sea coordinates was plotted. Ground crews removed the brush that camouflaged the aircraft's position. The reconnaissance version was known as the S-17. Its camera was placed in the fuselage, accessible through the cockpit. Top speed on a reconnaissance mission was close to 200 kilometers an hour. Altitude was 10,000 meters. With the mission completed, no time was lost in delivering the film to the mobile lab. It was located nearby, central to other camouflaged airfields. Specially trained technicians in the mobile labs did not have to improvise. They had all that they needed to process and develop the film. Intelligence information provided by the recently completed mission was transmitted to headquarters without delay. Although they lived much of their life outdoors, ground crews did not lack for many of the comforts of home. Wholesome food was plentiful. The saying that an army marches on its stomach could easily have applied to the Swedish Air Force crews at their remote airfields. A shared sense of purpose made the system work, but the simplicity of Air Force military operations in outlying areas belied the lethal nature of the work being done. The dive bomber version of the B-17 carried 680 kilos of bombs. It was armed with 2 machine guns in its wings and 1 movable machine gun at the rear of the cockpit. Dive bombing techniques and their effects on pilots had been studied in Sweden since 1934. It was reported that almost every dive resulted in a blackout. The pilot lost his eyesight, but could hear the engine running. The increase in engine noise told the pilot that it was time to pull back gently on the stick until his eyesight returned. To reduce the physical strain on the pilot and make the dive bomber less vulnerable to anti-aircraft fire, Saab engineers developed a bomb sight that allowed shallow dive angles and an automatic bomber separation during pullout. The bomb sight was a mechanical computer and one of the first of its kind in the world. This produced a dramatic increase in Swedish bomber efficiency. In late 1938, to enhance pilot efficiency, the Swedish Air Force issued an order of 35 North American NA-16s for an advanced training aircraft, known in Sweden as the SK-14. It was constructed under license, first by ASJA and later by Saab. North American constructed 2 aircraft as patents for Swedish manufacture. The SK-14 was originally powered by a 455 horsepower Wright Whirlwind engine. 136 SK-14s were produced. Maximum speed was 300 kilometers an hour, with a service ceiling of 7,200 meters. The SK-14 was agile and sturdy enough to give pilots ample opportunity to hone their dive bombing skills. A domestically designed and built Swedish trainer was the Saab 91. The prototype of the 91, also called the Sapphire, took its first flight in 1945. The 91's power plant was a de Havilland Gypsy major engine generating 147 horsepower. Speed was 248 kilometers an hour. The last propeller-driven aeroplane built by Saab was the B-18. The B-18 also took on reconnaissance, dive bombing and maritime missions. It originally had 2 Pratt & Whitney twin Wasp engines. Later versions flew with Daimler-Benz power plants. Development of the B-18 was described as difficult, and it had a poor accident rate. Out of 244 aircraft, 44 crashed between 1944 and 1959. This led, in 1949, to the installation of ejector seats, which had originally been installed for the Saab J-21 fighter. Despite this, emergency escapes were successful in only 4 out of the 44 crashes. At the outbreak of World War II, development of the B-18 was delayed so that Saab could concentrate on building more B-17s. Saab engineers used the delay to give the B-17 self-sealing fuel tanks, armor protection for the crew, a new bomb bay and bomb sight configuration. It was the most complex aircraft in Swedish Air Force service at the time. Altogether, the B-18 had 15,000 components. The crew of 3 had to contend with 160 levers, controls and buttons and read 45 instruments. The first version of the B-18 was considered underpowered and was transferred to the Strategic Reconnaissance Wing. It was given the designation S-18. This had a cruising speed of 390 kilometers an hour, and it flew at an altitude of 8,700 meters. The S-18 was modified for its new role with 2 Hasselblad cameras in the glazed nose. It was also fitted with a special night camera that produced excellent photographs in combination with the use of flares. The S-18 flew with 3 wings of the Swedish Air Force. As was the case with B-17 reconnaissance missions, the Air Force used mobile laboratories to speed the processing of film. In 1949, the S-18 was the first aircraft in the Swedish Air Force to carry radar. It was fitted with an American design that had a range of 100 nautical miles. The radar and a radio altimeter were installed in a pod beneath the nose. The B-18B carried 1,500 kilos of disposable armament. This included bombs, rockets and torpedoes held in the bomb bay and hardpoints on the wings. The B-18B was the version fitted with more powerful Daimler-Benz engines, each generating nearly 1,500 horsepower. Its top speed rose to 540 kilometers an hour with a range of 2,400 kilometers. This made it one of the fastest bombers of the Second World War, a far cry from the Junkers Ju-86 that was so slow that Swedish officials knew enemy fighters could circle around it as long as necessary to shoot it down. A new version of the Saab TOS bomb sight was developed and installed on the B-18B. This allowed a more shallow dive and more accurate targeting. The B-18B was the first true attack aircraft in the Swedish Air Force, in part because it was also the first Swedish aircraft to carry rockets. These were normally carried under the wing and below the nose of the fuselage. The maximum load of rockets was 12. To fire the rockets, a new gun sight was installed. And because this version didn't carry bombs, the crew was reduced to 2. The B-18's most unusual role may have come during testing of Sweden's version of Germany's V-1 rocket. In November 1943, a V-1 test rocket crashed in southeast Sweden. 2 weeks later, another V-1 was found. 2 more missiles were found in 1944, one of which was a V-1, but the other, a V-2, caused a sensation. The Swedish Navy saw the rocket as a new kind of torpedo. The Army promoted it as an alternative to the anti-aircraft gun, and the Air Force recommended its use as a pilotless aircraft. The trick was understanding how it worked and copying the technology. But this was easier said than done. One test with the B-18 went terribly wrong. The sequence was shot from several angles. From the B-18's fuselage, the missile is seen dropping from its cradle, and all appears to be going well. But as the missile begins to go off course and explodes, the chase plane comes into view, narrowly avoiding the missile. The view from the chase plane is even more dramatic. The plane passes through the missile's explosion and the shrapnel. Fortunately, no one was injured. Another film record shows an uneventful test. The chase plane's camera follows the test missile flying over the Baltic Sea. In 1948, most missile development was transferred from private industry to government facilities. Sweden went on to become a pioneer in the development of radar-homing anti-ship missiles. Sweden also pioneered in the field of commercial aircraft. In 1943, Saab approached Scandinavian Airlines, suggesting a replacement for its Douglas DC-3s. The project was approved, and the proposed aircraft became known as the Saab 90 Scandia. The Scandia was a top-quality aircraft, but it became obsolete because of its unpressurized cabin and underpowered engines. Only 18 were built. But while Sweden was not committed to competing in the transport aircraft arena, it was determined to enter the jet age. Saab was hard at work on its own jet design, but as an interim measure, the Swedish Air Force turned to Britain's de Havilland Company for the turbojet Vampire. The production Vampire made its first flight in 1945 and was powered by a single de Havilland Goblin engine. The J-29 was designed as a jet from start to finish. It was the first Western European swept-wing jet fighter to be put into large-scale production. Design started in 1945 and it first flew in 1948. A British pilot was chosen to head the test phase for Saab because Sweden had no test pilots with jet experience. The fuselage was given a barrel-like shape with a central air intake and a straight air duct to the engine in the rear of the fuselage. The shape led to the nickname Tunnan, or flying barrel. The round fuselage also housed the aircraft's armament and fuel. There was also room for fuel in the wing and provision for 2 drop tanks. The J-29 was powered by de Havilland Ghost turbojet engine. It was built under license in Sweden. Later production versions were fitted with an afterburner. It had a top speed of nearly 990 kilometers an hour. The airframe was designed to withstand maneuvers at 8 Gs at low altitude. The J-29 caused quite a stir in Eastern as well as Western Europe. When the first deliveries were made in 1951, some serious safety problems arose. Pilots were not familiar with the flying characteristics of a swept-wing aircraft. Flights in simulators and the 2-seat training version made the conversion easier. Like its predecessors, the J-29 was deployed to remote facilities in wooded areas. The technology of aircraft might have changed, but the philosophy on how best to use them had not. In May 1954, the J-29 set a record by flying a closed course at an average speed of 910 kilometers an hour. The next year, a formation of 2 J-29s flew at the record-setting pace of just under 840 kilometers an hour. Improvements continued to be made over the next few years, until the J-29 became the first Saab aircraft to go to war.
Independence came to over a dozen states peaceably, but in the Belgian Congo, freedom was followed by rioting and army mutiny, a reign of terror and disorder. United Nations troops were called in to avert total chaos. For months, the political pattern kept changing with kaleidoscopic speed.
In September 1960, a contingent of the Swedish Air Force was sent with 5 J-29s to the Belgian Congo. The assignment lasted 4 years. A few months earlier, the Congo had been given its independence. Then, the Soviet-backed province of Katanga broke away and declared its autonomy. The Congo asked for United Nations intervention. When 10 light aircraft and 1 jet-powered Fouga Magister, armed with guns, rockets and bombs, began successfully attacking the Congo, the UN decided that combat aircraft should be added to its force. Sweden bore the greatest burden, but India and Ethiopia also contributed aircraft. The J-29 was chosen because of its low fuel consumption, important for the long distances to be flown in the Congo. Its primary missions were air defense, attacks on airbase installations and close support of ground forces. But reconnaissance was also an important assignment. In 1962, 2 reconnaissance J-29s were airlifted to the Congo by an American transport. The Katangan Air Force was given reinforcements by the Eastern Bloc. Then, in January 1963, 4 J-29Bs were shipped to the Congo, just in time for the final action against Katanga. The Katangan Air Force was wiped out. When the war ended, the 2 reconnaissance J-29s were returned to Sweden. The 5 remaining J-29 combat versions were scrapped in Africa. Like the J-29, the J-32 Lansen was a swept-wing aircraft, but it was considered an entirely new class of aircraft. It was the first 2-seat Swedish jet with built-in search radar. Designers made special effort to integrate the electronic and weapons systems to provide the Swedish Air Force with a true all-weather attack aircraft. The J-32 was armed with 4 30mm cannon and Sidewinder missiles. Unguided air-to-air rockets could also be carried externally. Bombs or anti-ship missiles were also part of the potential armament. The Lansen, or Lance prototype, first flew in 1952. Production began the following year. The J-32 remained in service until June 1998. Not long after the go-ahead had been given for design and production of the J-32, the Swedish Air Force began drawing up specifications for a new single-seat fighter that could intercept enemy aircraft. The new aircraft would need supersonic speed, a high rate of climb, excellent range and endurance, and the ability to carry a heavy load of weapons. But such an aircraft would also push pilots to the edge of their endurance. The Swedish Air Force undertook a testing program to determine what pilots' limits might be. Researchers then sought a balance between what a new aircraft could do and the forces a pilot could withstand. Not only would air pressure be a factor, but G-forces as well. In addition to bomber interception, dogfighting would also be required of the latest aircraft design. In 1949, attacks by fast, high-flying enemy bombers were considered the greatest threat to security. To meet the threat, Saab initiated Project 1250. The result was the J-35 Draken, or Dragon. The Draken was designed with a double delta configuration. This met both high and low speed requirements and enabled the Draken to perform short takeoffs and landings necessary in remote areas. The first prototype flew in October 1955. In January 1956, the Draken exceeded Mach 1 in a climb without an afterburner. In 1960, an updated version of the Draken exceeded Mach 2 in level flight. It was fitted with Rolls-Royce Avon engines that were improved with each new version of the jet. The last type generated more than 17,000 pounds of thrust. The main armament was the Sidewinder missile, two 30mm cannons and air-to-surface missiles. The Draken was designed to be economical to maintain. This was especially important for countries with limited resources. A team of 7 could rearm and refuel it in as little as 6 minutes. Ground crews used hardpoints on the wing for missiles. Crewmen opened the leading edge of the wing to service the cannon. The J-35 had a combination of bag and integral fuel tanks. The Draken was intended primarily as an interceptor, but it showed itself to be a good dogfighter as well. It had target acquisition radar and a Saab collision course sighting system. Later versions of the Draken were armed with the Hughes Falcon missile. With the help of the Draken's targeting computer and radar, the Falcon was capable of acquiring a target in all weathers. It was made under license by Saab. For a time, the Draken was the most advanced fighter in Europe. It was exported to Finland, Denmark and Austria. Similar efforts were made to export another Saab product of the time. Like the Draken, the Saab 93 featured a unique design. But the 93 stayed firmly on the ground, and advertisements for it featured loads of luggage rather than loads of bombs.
Saab 93 har dessutom ett härligt bäddutrymme. Ger god plats för allt vårt bagage.
The reconnaissance version of the Draken, the S-35E, didn't carry bombs. It carried 9 cameras. The limited space in the nose led to the development of a new type of camera made by the French. 5 of the cameras were in the nose, 4 were placed in the wings instead of the normal 30mm cannon. The S-35E pioneered development of a new infrared reconnaissance system. The equipment was carried in a special pod. Range was greatly increased with the introduction of drop tanks. With these tanks, the S-35E could fly up to 3,000 kilometers. At first, Saab didn't think that a trainer version of the Draken would be necessary because company test pilots considered it very easy to fly. But most Air Force pilots did not agree. But the Air Force only required new pilots to fly 1 year or an average of 175 hours before making the transition to the Draken. 25 of the original Drakens were converted into 2-seat trainers. The Air Force also acquired flight simulators. Draken fighter wings further refined the policy of ensuring the survivability of units on the ground and below it. And again, the aircraft's sturdy design and simple maintenance needs enabled it to fly virtually non-stop, with one pilot completing a mission and another ready to take his place. Sweden's abandoned mines were also utilized as command posts, crew quarters and aircraft hangars, and the Draken's relatively small size allowed it to be housed in close quarters in time of emergency, taking to the skies in case of attack. In 1985, 66 Drakens were updated to the J-35J configuration. The modifications were mainly done to the weapons system, which allowed it to accommodate up to 6 air-to-air missiles. In addition to a top speed of better than Mach 2, its rate of climb was 16,000 meters per minute. The J-35J could fly at supersonic speed, even while carrying 4 drop tanks and 2 missiles. The Draken was Europe's first supersonic combat aircraft, a great engineering achievement that was undertaken when very little was known about how to make an aircraft capable of flying faster than sound. And in the case of the Draken, Saab designers took a great aircraft and over the years only made it better. The tensions caused by the Cold War and the Vietnam conflict served to increase concerns about the survivability of airfields. This was especially true in Europe, where the distances between potential targets was less. The French explored ways to decrease reliance on airfields with the Dassault Mirage 3V. The V took its first flight in 1965. It had 8 Rolls-Royce lift jets. The British had greater success with the Hawker Siddeley P11-27 Kestrel. The Kestrel project evolved into the Harrier. Saab designers were also inspired to take advantage of new technological advances. Their ideas ranged from jet aircraft that took off vertically and transitioned to forward flight, to aircraft with a swing-wing configuration. But designers settled on a foreplane fitted with flaps ahead of a main delta wing. Wind tunnel tests were conducted. They showed that the foreplane served as a lift generator, making it possible to land at very low speeds. At the same time, the foreplane did not prohibit supersonic speed. This met the strict requirements of the Swedish Air Force without resorting to expensive variable wings or vertical thrusters. The results led to the creation of the Saab 37 Viggen, or Thunderbolt. Building the Viggen was the biggest industrial project in Sweden's history. The prototype made its first flight in 1967. The first operational squadrons of Viggens were established in 1972. The fighter version has a more powerful engine, a Doppler radar and better hydraulics, which provided enhanced maneuverability. The Saab 37 has been designed for a no-flare approach to landing, with a rate of sink of a little more than 5 meters per second. This required the creation of a special landing gear, able to absorb an enormous impact. The Swedish Air Force required that the 37 be supersonic and able to operate from bases near highways. Its landing distance had to be the same as the J-29, about 530 meters. To meet this requirement, Saab developed a titanium thrust reverser integrated into the rear fuselage. The device redirects 60% of the 37's thrust and works well even on icy runways. This is the only one of its kind on a single-engined aircraft. Pilots who fly the Viggen are well accommodated. The cockpit is air-conditioned, heated and pressurized, and it's protected by a bird-proof canopy. The advanced avionics package includes a head-up display for attack. The display is linked by an air data computer to a digital fire control system. For protection, the Viggen has an electronic countermeasures package and radar warning system. There's Doppler radar and a radio altimeter for navigation. A tactical instrument landing system is geared towards all-weather use. There is also a guidance system for blind landings. Armament includes a 30mm cannon. There are 3 hardpoints under the fuselage and 4 under the wing for weapons, such as 2 Skyflash missiles or 4 Sidewinders. For ground attack, it carries up to 24 135mm rockets. Final versions of the Viggen were upgraded with terrain-following radar and a digital data bus for true multi-role capability. This effort was undertaken to allow for compatibility before the next generation Swedish fighter, the JAS-39 Gripen. Contracts for design and manufacture were signed in 1982. The first Gripen squadron was declared operational in the autumn of 1997. The Gripen has the same basic foreplane and main delta wing design as the Viggen, but is 40% smaller and lighter. The name JAS is the Swedish acronym for Interceptor, Strike and Reconnaissance Aircraft. The same pilot flies all 3 missions and changes from one to the other with the press of a button. The pilot gets his information through an air-to-air tactical information data link system. This allows real-time exchange of mission information within tactical units. The pilot has enhanced situational awareness and can make better use of his weapon systems. Altogether, 30 computers are involved, including a triple redundant fly-by-wire control system. The cockpit display provides information from Doppler radar and allows look-down, shoot-down capability. The Gripen can carry the AIM-120 AMRAAM missile, an advanced air-to-air missile, and a 27mm Mauser automatic gun. The 2-seat Gripen has the same avionics suite and armament as the single-seat version, with the exception of the gun. Performance and flight characteristics are virtually identical. The control and display functions are the same in both the front and back positions. The Gripen has a single General Electric turbofan engine that generates 27,500 pounds of thrust with an afterburner. It's supersonic at high and low levels. It has a retractable fueling probe, which increases its range. For pilot safety, it has an ejection seat that is operational at 0 speed and 0 altitude. The Gripen's ground crew is considered part of the aircraft's weapons system. The maintenance routine is technologically advanced but operationally simple. 5 crewmen and 1 technician refuel and rearm the aircraft in under 10 minutes. And the appropriate equipment for the Gripen's different missions can be installed at even the most primitive roadside bases. For wartime maintenance, the Gripen lands with a characteristically steep descent, using its canards as air brakes. The Gripen's approach is similar to that employed in a carrier landing. An operational landing would typically be on an ordinary road, because the Swedish Air Force still considers the national highways to be a system of air bases. This enables aircraft to be stationed in many locations immune to enemy detection. Another option for Gripen operation is called a Base 90, a hardened roadway measuring 860 by 10 meters. It's just another example of the Gripen's practicality and versatility. It's also Saab's claim to fame. In 1995, Saab signed an agreement with British Aerospace to market the Gripen abroad. This was a vote of confidence for Saab's handiwork and recognition of the Gripen's true potential. But this is not surprising. From its humble but optimistic beginnings in 1914 to the present day, the Swedish aircraft industry has consistently beaten the odds by making more from less.